A first-order differential equation is homogeneous if it can be expressed in the form the derivative of y with respect to x equals f of x y over g of x y, where both f of x y and g of x y are homogeneous functions of the same degree. A function f of x, y is homogeneous of degree n if f of t times x t time y equal t to the power n times f of x, y for any t. For example, f of x, y equal x squared plus y squared is homogeneous of degree 2 because f of t times x t times y equal t times x squared plus t times y squared equal t squared multiplied by the quantity x squared plus y squared. To solve a first-order homogeneous differential equation, use the substitution y equal v times x, where v is a function of x. This substitution converts the original equation into a separable form. Taking differential on both sides with respect to x is the derivative of y with respect to x equal v plus x times the derivative of v with respect to x. Substitute y equals v times x and the derivative of y with respect to x equal v plus x times the derivative of v with respect to x into the original differential. Equation becomes v plus x times the derivative of v with respect to x equal f of x v times x over g of x v times x. Rearrange the resulting equation to separate the variables v and x. Then, integrate both sides. Integral the derivative of y with respect to x equal integral f of x, y over g of x, y. After integrating, solve for v and substitute back v equal y over x to obtain the general solution in terms of x and y. Example: consider the differential equation the derivative of y with respect to x equals x square plus y square over x times y. This is a first-order differential equation, and we need to determine if it is homogeneous. To solve it, we check if it is a homogeneous differential equation. A first-order differential equation is homogeneous if it can be written as the derivative of y with respect to x equals f of x y over g of x y, where both f of x y and g of x y are homogeneous functions of the same degree. We use the substitution y equal v times x. Here, v is treated as a function of x. Substitute y equal v times x and the derivative of y with respect to x into the original differential equation. The quantity x squared plus v times x squared divided by v times x squared. Simplify the right-hand side 1 plus v squared, all divided by v. Substitute v plus x, the derivative of v with respect to x, equals 1 plus v squared, all divided by v. Isolate x times the derivative of v with respect to x equals 1 over v. Rewrite the equation to separate x, and the derivative with respect to x is v times the derivative with respect to v equals the derivative with respect to x over x. This separation allows us to integrate both sides is v squared over 2 equal natural log x plus c here. C is the constant of integration. Rearrange to solve for v. The square of v equals 2 times the natural log of the x plus c prime, where c prime equal 2 times c is another constant. Substitute v equals y divided by x back into the equation, become the square of y divided by x equals 2 times the natural log of x plus c prime. Rearrange to the final form. The square of y equals x squared multiplied by the quantity 2 times the natural log of x plus a constant c prime.